Okay, so let's get started on our curriculum and learning chemistry and what chemistry is and how to do chemistry. Um, Chemistry really is the study of matter. So, of course, all the matter in the universe, and we'll get into all the protons, neutrons, electrons. What is an ion versus a regular atom, compounds. All those things are coming up. For now, let's kind of just, it's the study of matter and being able to explain and take matter through these changes, and then explain what's happening at the particle level. Chemistry is it's a mathematical science, but for this class, no complicated math, but just a lot of mathematical type of reasoning goes into the class. So a lot of what we're going to do is explain something, and I'm going to show a little demo here. Explain something that I can see and try and explain what's going on at that level that I can't see at that atomic level. Even with a microscope, we can't see it, so we're using these models to predict what's going on. Let me put my goggles on. I have just an iron nail here. I'm going to grab it with some tongs. And I have a little butane torch. Butane is a gas, a very flammable gas. And if I try and light this nail on fire, I can get it glowing red hot after a while. But the iron, we would say, is not very combustible at all. So nothing's really happening. Let me take a different metal. The reason I have goggles on is just to be careful because this one is a little different. I grab a piece of magnesium metal. This metal is more reactive. And when I light this one, it burns super bright. And you can't really stare at it as you can on the video, but it's a really bright flame. So the same process, iron did nothing basically from what we saw. I got a little bit hot, but it didn't glow bright. It didn't burn bright. The magnesium burns super bright. Magnesium was actually used before we had just regular flash cameras. If you see the old Western or old movies where they had the first photographs, how did they get the flash? They used magnesium powder to get a really bright light. So magnesium burns really bright. We say it's a very active metal. We'll be able to explain all of that. Why is it? Later on in the class. And we say, well, iron doesn't really burn. But if I change the form of iron, so this is some steel wool that I've expanded and opened up. So instead of a nail, this is the same material. The iron nail is basically steel. Steel is a material that's made up of mostly iron atoms, but with some carbon and some other things in. So let me take this steel wool, and when I light it, it is burning, not nearly as brightly as the magnesium, but you can see it burning away here. So it's the exact same material. Essentially, it's steel, a mixture of iron and carbon. And in the nail, it didn't burn at all, but now I've expanded it into the steel wool, and I can get this to burn rather nicely. So we're going to be explaining, so why is that? What happened? What did I change? Those are some of the skills, of course, that we'll build up and be able to explain what's going on at the atomic level. What did I change that causes magnesium burns super bright, iron doesn't burn unless I expand it into these fine steel wool fibers, then it will actually burn. So we're going to be working with the particle model of matter, and you're familiar with that. So for right now, if I say, well, if I have a solid, it's these things uniformly arranged. There's a force holding those particles or atoms or molecules or whatever you want to call them together. This marker doesn't show up very well. So that would be a solid. Let me heavy that up a little bit. So for right now, we're not even going to distinguish the magnesium and the iron. A liquid would be more random, still in contact. The particles are in contact with each other, but it's a much more random fluid kind of situation. Solid, liquid, and of course gas. Let's see, stay on camera. Gases are more spread out. Now the other thing that we can do with this particle model, for now, of course, we will be using the chemical formulas for all these later, but for right now we can represent them. What if this gas is not just a pure gas? What if it's air. Air has nitrogen, oxygen, carbon dioxide, argon, all kinds of things in it. So I could show at this level, I could say, well, it's got something in it, right? So there's one type of particle, there's another one. Let me give this a little happy face, right? So there's another type of particle in there. And so we can represent that with our particle models. And that's how we're going to really start this class, doing a lab, learn some lab techniques, and then be able to represent what happened in the lab at this level. Another thing that we can look at, looking at the liquid, is what if, so I'm just showing one type of particle. What if I've got something that's called a solution? You're going to be working with solutions today. So a solution is mostly water, and there's something in the water. So I could say, okay, that's the water particle, there's the something else that's in the water. So we can represent mixtures with this model as well. In the lab, let me bring my triple beam balance over here. You're going to be working with changes in mass. So we're going to take matter through some really simple processes to begin with here. Take matter through some simple processes and look at what the change in mass was for that process. So the triple beam balance is here. I think some of you have experience with this thing. Make sure everything's in the slots. You even this thing out. Make sure the pointer points right at the line. If it's off, there's the fine adjustment right here on the end. Make it so it's right on the line. If you're weighing something, now I put in the instructions, weigh to the nearest 1/100th of a gram. If you look at the scale, there is no lines for 1/100th of a gram. So how do we do that? So if I put an object on there and I try and make it balance, I'm just going to go kind of quickly, let it settle. I'm not going to wait for that in the video, but so I have it balancing, and I say, well, it looks like about 2.6. So let me try and mark that. So it's like here, 1, 2, 3, 4. So of course 2 grams, each of these is 1/10 of a gram. And I'd say, well, it's like 2.6, but well, what if it's right about here? I can actually, so what we have was we have the lines to 1/10, but I can estimate an extra digit out of that. So it's 2.6, and it's just barely past the 2.6, I'm assuming. Okay, so I'm going to say, boy, it's just off the 2.6. So what's the mass? 2.61 grams. So I'm estimating that last 100th. So you don't have to be dead on accurate, just get as close as you can. I did give you the magnifying glass, you don't really need to use that for this, but estimate that last digit so you got to 1/100th of a gram. Yes, I'm on the screen. And that's how we're going to use this. Then you take it and you put it through a change and you weigh it again and get your change in mass. And we're going to kind of talk about this. So part of this is being able to use these scales accurately. With some skill, these are pretty accurate. You can get to 1/100th of a gram. So that'll be part one. You're going to take this piece of steel wool after you've weighed it, record the mass, open it all up, kind of like I had that other one, and then weigh it again and talk about any changes you have. In part two, you're going to be taking 2 solutions. So you have the 2 smaller beakers that I gave you. You're going to pour about 20 milliliters. These beakers have some lines on them. So just to about 20 milliliters. Not very much, we don't need much. You do not have to be accurate with these. Normally beakers, these measurements are not very accurate, these lines on here. For this, we're not making any calculations with these measurements, so for right now you can just pour and get it to about that line. You weigh the 2 solutions separately. I don't have any solutions in here. And then you'll just pour one into the other. It does not matter which one you pour, but you just want to mix the 2. You will see a precipitate form. And then we're going to measure the mass after. That'll be our first 2, and then of course we're going to work on representing at the particle level what's going on, why did we do the procedures, if we see a change in mass, why. One thing I do want to be careful with here, because we're going to get into significant figures. In chemistry, what if you said, we didn't see any change, the change in mass is 0. In chemistry, there's a difference between 0 and 0.00. Right, that says something different, and that's something that we will get into, but it tells us something about the accuracy of this thing. So with that, let's get started, and I will have another short video just for what part 3 and 4 of this first lab are.